His myriad contributions to the institutional development include the development of academic programs on economics, quantitative finance and data sciences, and analytics with partner academic institutions. He was the director and professor of econometrics, Mumbai School of Economics and Public Policy, University of Mumbai from 2014 to 2017. Was also a chairperson ad hoc board of studies in economics, University of Mumbai, 2015 to 17. Also a member of various statutory committees like Board of Studies on several universities. Again, a member technical advisory group for composite leading indicators for the Indian economy, the Bank of India. And this is just the beginning of it all. The topic of his PhD dissertation was studies in the theory of business cycles with special emphasis on real business cycles and their application to India. Awarded with the Smarts Visiting Fellowship from the University of Cambridge, he also delivered a series of lectures at Dartmouth College, USA. Over 55 papers and articles by him have been published in various books and journals over a period of time. His areas of interest include economic development, collective action for development, data analytics for public policy, economic history of India, applied econometrics, and the name of few. Successfully guiding 15 PhD students so far, he is here to deliver a public lecture on the topic Geography and Regional Planning, an application of geographically weighted regression at the event. This paper examines the relationship between public amenities at the block level and malnutrition outcomes in Maharashtra. It uses the technique of geographically weighted regressions to uncover policy impact, heterogeneity over space. Over to you, sir.
Thank you. Thank you so much. Am I audible to everybody here? Okay. So what is this paper about that I did with my colleague Neeraj? Essentially, it actually has 2 or 3 different threads around it. Okay, and let me kind of give you a background of all the 3 different threads that are before we start looking at. One, when we look at issues like malnutrition, which are policy challenges, right, we really don't have any economic theory which tells you that why do we the dependent variable. Okay. Okay. Right? So basically, we don't have theory. Right? We don't know, for example, what are the factors that influence malnutrition. So very theoretical. So, but it's a problem that we need to solve. So how do we learn about what the variables are, what the policy is? Right? So we undertake we learn it from the data. Right? We learn it from the data. And now increasingly, machine learning techniques are now being used widely in data science to infer relationships. Right? So this, in one sense, is an application of machine learning to solving public policy problems at a very basic. Now, what do I mean by machine learning? Essentially discovering patterns from the data. Now, machine learning is a little bit more complex. Normally if you fit a regression, right? So suppose Y is your dependent variable, so malnutrition is your dependent variable, and your X explanatory variable. You don't even know what the explanatory variables are, but suppose you find some machine learning method choosing what explanatory variables are. Right? When you are actually dealing with very large geographical spaces, right? Suppose you're looking at the whole Maharashtra and your data are gram panchat level or block level data, right? Then it is really unrealistic to expect the same relationship to fit across the whole region. Right? For example, the impact of clean drinking water might help in reducing malnutrition, but that might only happen more strongly in certain regions, less strongly in certain regions. In those regions, say, access to electricity might be more important. Right? So there is bound to be a lot of regional variation, spatial, geographically specific variation in estimated coefficients, policy coefficients. And we currently really have no reliable way of inferring that. Right? You can't do it with a standard econometric technique because suppose we are looking at this exercise now, my exercise involves block level data. There are 343 talukas in Maharashtra. So you have 343 data points. You can't have a dummy for each taluka because you will end up having 343 dummies for each taluka, right? So the econometric model will not go through, will not be left with degrees, right? So how do you go about that? That is the second kind of a technical issue that I'm going to talk about. That so if you want to fit space, there are models over space, right? And the coefficients are varying. And also one important point is that if you actually, if the model coefficients are varying across space, and if you fit a single regression where models are constant across space, then theory says that that model is misspecified. It's not really the correct one, right? The coefficients are neither unbiased nor consistent because they have different distributions in different regions. What you get is a very mixed kind of a right? So that's the second thing that I'm talking about. The immediate policy implication of this is what? Now, we must have all heard about the 74th Amendment. And in the 74th Amendment, now we have essential decision making at the Gram Panchayat level for about 27 different subjects. And the key word in government policy, if you talk to officers, then the key word is convergence. Right? What is convergence? You have different departments, and they say that different departments must work in consonance with each other. Should not work at cross purposes with each other. But beyond that, we really don't have an understanding of convergence. I mean, what do you mean? There might be, say, 27 different departments handling the 70 different subjects. Now, do you mean that all these 70 different subjects have to be converged together across all the parts of the across the state in the same way? Or is it that what departments have to work together where depends on different regions? Right. So, for example, in certain parts of the state, it might be a combination of access to clean drinking water and better electricity. That might actually have a larger impact on malnutrition. In some other parts, it might be access to transport facilities and maybe clean drainage. Right. And that is so the departments that converge together. What kind of convergence to do will depend upon what is the problem that you're going to solve and what are the regional specificities, so the regional context. And there is no way to understand the context a priori without actually looking at the data. So learn that from the data. Other important implication of this is, now how are district plans made? Right, you have plans coming from the Gram Panchayats, right, which are aggregated at the district level, and then the district plans are aggregated at the state level and so on. Right. But it might actually be a case where one particular Gram Panchayat or one particular taluka is a part of a larger region where a specific kind of a convergence is really important. So there will be a group of 15 talukas where access to clean drinking water and access to electricity might be really important. In which case, if you're planning, if your policy variable is to have an impact on malnutrition, then it's important that all these 15 talukas focus in a concentrated way on converging these two departments. So then there had to be a procedure where you actually reconcile the Gram Panchayat GPDP plans of all these different types of villages at the taluka level and bring in some consistency so that the overall in the region, what we are doing is actually consistent with what will work, what is shown to be work, right? Okay, and that what level, whether it's the collectors of some 2 or 3 particular districts which must work together in water, or videos of some talukas across 2 districts which must work together, right? All that can be inferred from the data. Right? That is the kind of a thing I'm going to do. And the fourth thing that I want to do with this is bring to you the importance of how econometrics is changing now as a discipline. Okay, and the kind of data that we have. Now, for example, the data that I'm working with is what is called the Mission Antyodaya data. So what is Mission Antyodaya? In 2019, the government of India started with a very detailed, consultative effort to create Gram Panchayat development plans. In the convergence mode. But we needed to have the data. So we now have a data set for 98% of the Gram Panchayats in this country, which cover a whole host of variables. Right? For example, whether there is a bank, actually what is the whether the bank in the village. If it's not there, how far is the bank? Whether there is a road, if the road is kacha or pakka, whether there is access to clean drinking water, what is the access to electricity, whether there is a school, how far is the school, whether there is an ATM, whether there is a business correspondent, if there is a public library, whether there is a pasture, whether what kind of houses there are. All that data is available across almost 2.5 lakh, almost 3 lakh gram panchayats across the country, right? So that's one data set. The other data set that we have is very useful, which is from a very large project called Shrubs. Has anybody heard of the Shrubs project? The Shrubs project is a project run by some people at Dartmouth College and some people at Oxford University, some people who work on development economics, who work a lot on in the data-driven way in the country. What is Shrubs? So all of you know that there are, for example, think of the economic census. That we have the economic census with the population census. So we have the population census from 91, 2001, 2011. Then there is the economic census. Then there is the socioeconomic caste census. Then there are a lot of other things, the policy interventions, like for example, the Prime Minister's, that road building scheme, right? You also have nightlight data. You also have satellite, other kinds of satellite data. So say think of one village, say Khawli Budruk, which is Vaikan. Now, Khawli Budruk is in 2001 census, 1991 census, 2011 census. It is in the economic census. It is in the socioeconomic caste census. It is in the PMGSY data. It is in the satellite, but we have no unique way of identifying it across all these databases. And suppose Khawli Budruk was a part of Khawli and then was separated, right? So, we need to also. So what the Shrubs project has done, it is just created unique identifiers for each of the villages in the country. So any village in the country, and also reconcile the data, villages and towns. For example, towns merge, villages merge, Gram Panchayats separate out. So all that difficult work Shrubs have done, and now you can actually identify each of the data sets. And then you can get a lot of estimates which you really want. Like for example, we have no data on village level poverty. Right? Okay, but what Shrubs has done is it has actually combined two data sets. Right? One is the socioeconomic caste census, where we have detailed data on set of asset holdings by each household in the village. You have I'm sure you also have heard of the ISDS database, Human Development Database, which is 2004 and 2011. It's a panel of a very large set of households, where you have data estimates on household consumption expenditure and household assets. And those assets are very similar to those in the ACCC, almost identical this. So what you can do is, what people have done is, they have regressed household level consumption on household assets, and then use that fitting function to actually estimate household consumption in all the ACCC villages. Right? And once you compare the fits which come, so your ISDS data, you already have consumption estimates. And if you use this method to estimate consumption ISDS data, the fit is very, very close. So this method actually does a decent job, which actually therefore we have been able to compute estimates of poverty in each village, each block, right? So that very nuanced kind of, and which is very important because many times, many initiatives work better if they are really granularly targeted. And it can be shown, for example, gains in poverty reduction substantially more if you have a very granular village level targeting compared to the whole district level targeting. Right? And that is why you need that granularity. Right? Now, when you deal with such large data sets, your econometrics becomes very, very complex. For example, the machine learning exercise that I'm going to talk to you about, even for Maharashtra at the block level, involves estimating very complex kind of, very complex set of numbers. For example, just doing this exercise on an i7 processor, right? The 16 GB RAM takes me about 1.5 hours. That's the kind of a computing time. If you do it for every gram panchayat in the country, then my data set is really huge. I can't do it here. So I need to have a big data kind of many machines working together. But then my mathematics of my computing exercise changes. So it becomes the kind of an interface between very large data, econometrics, computer science, etc. That is really where large scale econometrics is now heading. Okay, large scale data-based work, development, policy making kind of work is heading, and so that is really the future kind of work. So that's given that is the kind of background. This is the background of my paper, and I want to kind of talk to you about basically illustrate these points with the help of what I'm doing. Okay, so this is what this was. So keyboard. Thank you. Okay. So fine, this is just the mission Antyodaya. right? So what is Mission Antyodaya? That's clear here. It was adopted in the Union Budget 1718. It's a convergence accountability framework aiming to bring optimal user management to 27 departments. So annual survey of Gram Panchayats, and this is going to be a panel now. So you will get almost 3 lakh Gram Panchayats across years. Look at the rich data over 70, 80 kind of variants, right? Okay, so right. So what are the questions that we ask? Does one size fit all solutions work for malnutrition? So we have one solution, one model, and that model works everywhere. Or do we need to kind of have a varying policy mix, which will be regionally varied, right? Convergence of what and where? Right? If policy is going to vary regionally, then so what and where? And answers are likely to be very geography dependent in some cases. In some cases, they might be global answers. And you have no priority way of saying what works. Right? So you have to learn it from the data. Yeah. So clear. So we need a framework about organic thinking. So we look at issues in the context of malnutrition Maharashtra, mostly using the data from the Mission Antyodaya, then the SRUGS database, and the NG-NREGA data. You also know that NG-NREGA data are available at the level of the Gram Panchayat for several years across a host of activities. That's a very big data set. Right? And another thing that you really need to have, another skill that you need to have to do this is after to access, wrangle this data, manipulate this data. You can no more do it in Excel. That Excel is really not what Excel or SPSS are not what it means. You need to access to programming language. R or Python is really the way to go ahead. Right? Okay. So another important thing, as an econometrician, I'm focusing in this paper only on associations, not causation. So when I say, for example, access to roads leads to different impact on different parts, all that I'm saying is this is the data, this is the association with the data. Because causation requires you to have an identification strategy, right? And I don't have the data here to do that identification. But what this will give you is some paradigms, some way to think about this, right? Okay, so that's something. And identifying causation in a geographically varying sense, the economic doesn't even exist as of now. Right? So all the identification is happening on SRUGS data set. For example, what happens if you build roads, etc. What happens if you break big states into small states? That kind of work has done with excellent identification strategies. But those identification strategies have all been panel data, standard econometrics, rather than something that I'm trying to do here. So that kind of identification methodology probably doesn't even exist, and we need to work on that. So this is really there are lots of gray areas where we are standing on this, and right. Right. So what is the data that I'm using? My measure of undernutrition is for every Gram Panchayat. I have data on number of children in the Anganwadis and number of children and the number of children in Anganwadis who under 6 who are also underweight. Right. So that proportion gives me the percentage. Right. Then I have data on percentage of GPs having an Anganwadi, percentage. This is at the taluka level. So I've got all the percentage with respect to taluka level. But I can also do it at the Gram Panchayat. But the computing dimensions will become very large, and we still not be able to figure out that, right? So percentage of ST population comes from census, female literacy comes from census.
What is the LD?
Mission Antyodaya, right? Percentage of non-working women, percentage. So this is the kind of a data that we have. Okay. So public grounds. This is data is available for every single gram panchayat in the country, right? So look at the.
But actually, primary census abstract also have the data, but not so many variables.
Not so many.
No.
And this is for 2019, and you have to have it every year.
Yeah, but primary census abstract also.
Yeah, but that's now we just have 2011. No?
Yeah.
Yeah.
This will be annual.
Yeah. And this not only does it have this has number of farm ponds, Poshu Mitra in how we are there, government seed outlets are there, etc. All that data for various gram panchayats across departments. So women and child development schemes at the gram panchayat level, right? Fisheries, animal husbandry schemes at the gram panchayat level. So there's a farm pond, how many farm ponds are there? Irrigation, how much in the gram panchayat, what is the area under surface irrigation, etc. All that kind of a data now that we have. And then we kind of merge it with the data from the censuses using the SRUGS data set. Also from,
it is good for the Is it an income?
No, so it is basically how is median rural poverty defined. As I said, from ACCC data, we have consumption expenditures at the village. Right. So from consumption expenditures, you have the poverty line, state specific. You can compute the percentage of poor in a village. What I have done in this is, when I want to have the really the measure of poverty in a village, what I really have to do is to take in a taluka, I need to actually create a weighted average of all the populations in talukas weighted by percentage. I've been a little lazy in that, and all that I have done is I have found the median. So if I look at all the villages in a taluka, I've just chosen the median poverty distribution as a measure of median poverty in a particular taluka, right? Okay, but yeah.
Just related to the same.
Right.
You're considering relative or the absolute power?
Absolute poverty. India poverty is only absolute measures are only for absolute poverty. Another experiment. Right.
So how much is the T equal to the number of periods in the data panel in the panel?
No, this is only for one set.
Cross section.
Cross section. The cross section is about
So when we are talking about the panel, how much is the T?
See, now you'll get depend on what you're looking at. Like for example,
Right.
the vision answer they will come every year.
After
Right. If you're
2007.
looking at the shrubs, consumption, the population census data, then you have all those from 1991 till date. Right. And such people are fortunately also looking for people who will help them clean the data and put other things, because as you can make out, it's a massive kind of a job. They have developed an algorithm which is a fuzzy algorithm where it will match village names and with their foods, etc. But that also takes a lot of manual work. So that's a median. Now, okay. Now, what I have is look at the malnutrition spatial regimes. Now, how have I done that? How have the malnutrition spatial regimes come up? This is the map of Maharashtra talukas. When I put malnutrition data on talukas, this map already has latitude and longitude superimposed on it. So the moment I say malnutrition, I attach malnutrition data with this taluka now, malnutrition data will also get a lat long. So my computer knows what is the physical distance from this taluka to. So for example, my computer knows what is the physical distance from this taluka to this taluka. Right. Now what we are trying to do is to form regimes. So what do? I define a neighborhood. Right. So I'm talking about, for example, Y taluka, then there will be neighborhood of talukas around Y taluka, which will constitute the neighborhood. Right. And the value for the Y taluka will not just be the value for malnutrition in Y taluka, but it will be weighted average of the talukas in the neighborhood with a specifically chosen weighting function. So in one weighting function would be a Gaussian kind of function where in any direction, the further you go away from Y taluka, the weight decreases. And there are ways of optimizing it. Right. So what this has done is, now you see this coding. Right. What I've done is, I've done this for every taluka. So I get a distribution of this regionally weighted kind of regional, of malnutrition values. Therefore, for the entire distribution, I've kind of mean. Then I divide it into 4 regions: mean minus standard deviation. Below that, mean plus standard deviation, and above that. So I get 4 regions. Right. So you see this region, which has the lowest malnutrition, regionally, you get a special area where malnutrition is below 10.21. 10.1 is the state value is normalized at 100. So 10.1. If you move from Western Maharashtra to the middle and the kind of Marathwada, then you start looking at malnutrition becomes denser. And as you move towards Western Vidarbha and Eastern Vidarbha, right, malnutrition becomes so clearly see a geographical gradations, right? No, the previous one was here.
You have the touch sensitivity. The screen has a touch
That's
sensitivity.
it. Okay, so I can do that. That can go. Right.
Yes.
So you can see that, right? There's clear spatial map. Now, just looking at the distribution of malnutrition at taluka level, you will not get this picture, because actually a taluka, any taluka or any geographical data point is not a randomly distributed data. It's a part of a regime. Right? For example, area in the sugarcane in Y taluka is not a randomly chosen data. It's a part of a larger landscape that grows sugarcane because of various things. Right? And you need to be able to when you look at white taluka, you need to be able to understand there is a part of the largest sugarcane growing area, and so you need these ideas of labor. Right? So you get this. Okay, so now I'll just try to. This is median rural poverty, just data plotted. So bigger and darker points will mean greater incidence of poverty. And you again see this how the spatial, these are all tribal areas. Right? This is Palghar and all that. This is North Maharashtra. This is Danu. This is the Dharmi and yeah, Amravati. Then this is Gurgalchiroli, Bundia, Chandrapur. Right? So you see how the distribution goes. And if you make a spatial kind of, this is just the date, right? If you make the spatial kind of a thing, then you see how the space is, right? Southern Maharashtra, really, western southern Maharashtra is the lower incidence. This is rural poverty, okay? So urban issues are not coming into it, right? And therefore Mumbai, etc., don't come out to be rich regions, right? The richest, the least poverty incidence is really this western southern Maharashtra. Then as you go up, then you come to eastern Vidarbha, western Vidarbha, and then eastern Vidarbha, right? Again, so that's how poverty dimensions in the state are. This map has never been drawn before. There is never taluka level kind of. So we understand this. And so the point is, we don't, when we look at administrative regions, the point is that poverty is an economic process. It's a socio-economic process. There is no need, there is no reason why poverty or anything else should follow what's your administrative divisions. So in a sense, when you look at data from administrative divisions, you're actually creating an artificial division. No? For economic processes, there is little to even understand administrative division. So another advantage of understanding things from the data is to be able to actually overcome this artificial division of data. I could take data on Nagpur administrative division, Nasik administrative division, but that would actually mix up patterns. Right, some of these patterns will be, so if I say Amravati region, the Amravati region will be part of this. So two regions are getting mixed together. So that data really is a mongrel kind of a data. The Amravati region is not a homogeneous. Right, so there's another reason why you can actually learn from this, from the data. Yeah. Yeah, let me come to that. Yeah. These are the boundaries of Sangli and Solapur district, etc. No, because this is I've not mentioned it as malnutrition. Look at the malnutrition data. These are the lowest malnutrition.
The next slide is for poverty.
Yeah.
And the next slide.
Next slide is the spatial regimes in poverty. Right. Yeah. These are the spatial. So this is the lowest poverty.
Yeah, but
so what is happening? The important point is, so if you look at talukas like Jat, right, Jat or Kapli, which are on the boundary, which are drought prone, etc., which have issues of water, access to water, is rural poverty. Right. Okay. So what this point? This is making a point. It says, okay, if you look at Jat in isolation, then there is a problem. But if you look at Jat as belonging to a larger region.
But you mentioned look at taluka wise. As for taluka wise.
No, this is not taluka wise. That's what I'm saying. This is a region-based definition. So what it says that I'm not going to look at Jat as a particular taluka. But I'm going to look at this. I'm going to define a region around Jat, and the value for Jat will be a weighted average of the talukas around it in a certain neighborhood.
Because of that.
So what we're saying is actually the argument would be that Jat actually is a poor taluka in a otherwise.
Should be
No, it is because this is that's the point I'm trying to make. That Jat may be individually a poor taluka, but it's a poor taluka stated in a larger neighborhood as a neighborhood. Those are not poor, right? So this is why this definition of regions becomes very important. So it then says that the region, say for example, if a taluka here is a part of a larger region of poverty, and so issues that the dimensions of poverty become very different, no? The reasons for rural poverty in Jat or Koke Mankal will be very structured, they will be very specific to those talukas. Whereas if you look at Gadchiroli or Bhamarapat, they are largely region-wide. Right? Because there's the regional commonality. And this can't otherwise come out unless you do it this way. Right? Okay. So now one thing that I've done is we are trying to look at spatial agglomeration. So whether talukas which are like in particular values are actually clustered together. Right. So imagine say a classroom, right? And in the classroom, say school or a college classroom. Say FY BCom classroom would be the right example if anybody has ever taught BCom college. So there are some studious fellows who want to do CA, etc. Right? Ambitious. So they sit together in a class. Right? There are some folks who just come together, come to class to enjoy their levels, shops and businesses and want to have fun. So those guys sit together, right? So if you pick up a student at random, then you will be sure you can really expect the students around that student in a certain spatial neighborhood to also be more students. Whereas if you pick up a student who turns out to be a student who is not so studious, then you would expect students around that to be also. So that is a spatial agglomeration, right? Like districts are sitting together. District talukas with high levels of literacy are all clustered together. Talukas with low level. The alternative would be that they are spread randomly. The alternative would be that they are spread randomly. And the way to measure it, the classical way to measure it is what is called Moran's eye. Right? What is called Moran's eye. So what you really have a spatial weighting matrix. What's a weighting matrix? If you have 332 talukas, it is 332 by 332 cross matrix. And it will say, okay, so if there is a particular Jat taluka, the weights in that matrix will decline depending upon the geographical distance between the talukas. And my data knows latitude and longitude. Right? So it's a kind of a spatial correlation you can think of. Correlations over space, where you account for distances. Right? As you can see, this is, if you didn't really look at this, right, then this would clearly be the formula for covariance upon variance. So that is correlation. Right? An autocorrelation kind of a thing, really, if you get it in a time series context. So this is, but where the values are weighted. This is called Moran's eye. And the null hypothesis is that the data distributed randomly. The alternative is that they are clustered. A positive of Moran's eye would mean that the data are all clustered together. Right? Highly literate talukas are going to be clustered together. Moran's eye negative would mean that they are actually diffused. Right? So highly literate talukas are likely to be surrounded by lowly literate talukas. And Moran's eye being 0 would mean that the talukas are randomly distributed. Right? So I'm now going to look at various, and this is a very standard measure, right? So now I want to use that method. So basically, I'll give you one example of how this works. For example, if I'm using this for, say, some variable called index, right? Then you have, this is the Moran's eye statistic value, which is 53.148. The p value, as you can see, is very small. So basically, rejects the null hypothesis of random areas. Let's say there is positive clustering, right? And expectation variance, etc., etc. If you look at it graphically, right? So what you have here is, say, literacy, right? The value of literacy in each taluka on the x-axis. The average value in its neighborhood, which is called as spatially lagged on the y-axis. This gives you the correlation. Right, so this is the slope of the function, which is basically the correlation function. Yeah, and you can divide it into 4 regimes. Right, one regime which is high, so this is 0 because they are centered, right? If you take out the mean and normalize them, then obviously there are the mean 0. So all these talukas are where the value is high in that taluka and the value is high also in the surrounding taluka. This is where, for example, Mool, Chimur, Umre, Jalgaon, etc. What variable I'm looking at, the values in that taluka are less than the mean, and those surrounding are also less than the mean, right? And then this is where this is the other way, right? Where the values of that value are less than the mean, but the surrounding values are more than the mean. So basically, I've got 4 quadrants now, right? And now we're going to see pictures of that. So I'm now going to see this. Everybody understand what the Moran's eye basic idea is? Okay. Now for across all amenities in the Antyodaya mission Antyodaya, I'm going to show you. This is spatial clustering of rural poverty. Right now, it's not spatial regime; it is clustering. Right? So all these red areas are which are areas they are higher than average taluka level poverty, surrounded by areas which are higher than average poverty. The yellow areas are lower than average poverty, surrounded by areas which are lower than average poverty. The green are where poverty level is high in that particular taluka, surrounded by low levels. Right? Okay? And the oranges are low, surrounded by high. So broad patterns that it describes is clear to you. Right? Where is poverty in Maharashtra concentrated? Tribal belt. Correct. Right? This is the tribal belt. Yeah, Bangalore, etc. This is Gadchiroli. This is North Maharashtra. Right? That is where consumption poverty in Maharashtra is actually located. Right? Okay. Look at Anganwadi clustering. Where is Anganwadi in Maharashtra? They're all in this region. This is all. These are all areas where the amount availability is low, surrounded by low areas. Except this green, right, which is Gondia, which is a very powerful politician constituency. Right, so you see Gondia, etc., the Prof constituency stand out in many different clusters. But otherwise, you see the very unequal distribution of Anganwadis across Maharashtra. Right? But despite Anganwadis, if you look at the spread of immunization among children, spread of immunization among children is fairly uniform. You don't have that kind of clustering. The greens and the reds and the yellows, so orange are pretty small, right? So that's now. If you look at where do Dalits live in Maharashtra, this is the clustering, right? Okay, and there is certain hypothesis about agrarian serfdom and rural-based occupation, etc., which fits very well with this kind of a story. And this is 2011 census. Where are the tribals? They are the tribal clusters. Where is female literacy clustered in Maharashtra? This belt, right? And this, because there was a specific program run by the government between in the first decade of 2000, where there was a special drive for female literacy. But otherwise, you see special clustering of female literacy in Maharashtra as well. Where are the female non-workers in Maharashtra? Right? Okay, so women who are not working. Right? These are where female workers are clustered. These are the entire agricultural belt. So these are all women who are actually rural workers, but they are basically agricultural. Right? So they could be marginal farmers, agricultural laborers, and so on. These are more likely to be women who are housewives, who dropped out of the labor force. And you know that here, that as economic development happens, women work out, labor force participation drops, and so on and so forth. So this is the more developed region where you also see this matches with the lower poverty kind of a regime in Maharashtra. Right? So you basically have lower levels of female participation, labor force participation here. So in the story of, that's the whole point I'm trying to make, that stories of development are very regionally nuanced. Right? They're not for the whole Maharashtra. The whole Maharashtra is not the same, not a single state for all economic processes. And neither do economic processes follow the administrative divisions that we make of it. Right? They're spread all over. Right. Look at where the banking correspondents are available. Generally clustered in this part, right? Access to banks. Okay. Again, you see access to ATMs, access to internet, access to all weather roads, access to ration shops. Where are the kacha homes in Maharashtra? Where the groups and the huts, right? Where is the access to electricity in Maharashtra? Where is the access to healthcare? By healthcare, I mean whether you have a PHC in your village or a CHC community health center in your village, or you have access to healthcare within 5 kilometers of it. That is how I'm constructing the village. And look at where it is. Access to pipe drinking water. So what we have done is at least 50% of the households having access to pipe drinking water, I have qualified them in this data. And this is our access to clean drinking water. Primary schools. Access to primary school. Yeah. Where is agriculture employment clustered in Maharashtra? You can see women, women workers, agricultural occupations, poverty regimes. So you get a story of how women across Maharashtra are, are doing, right? Post offices. We thought every village is a post office, right? Access to veterinary care. Where is the work from Narega coming up? This is data on, I think, till 2021. Cumulative engineering days of work. Where are they? They are all in the tribal zones. Why? Because 2 or 3 things are happening. The forest rights act gets convergence with engineering, etc. And that is where there is demand for engineering. I've tried my best to start. We have factories who need engineering work. I've tried my best to create demand for engineering work in Satara, Sandi, Kolhapur. People don't just come forward because they don't need engineering work. Right? The rural wages are higher than what people can earn. Otherwise, it's higher than what engineering offers. So clearly, this tells you a story. Right? Okay. So now we come to my idea of a geographically weighted regression model. So what we really have is now, given this highly unequal geographical space, with very unequal and varying accessing public amenities, the impact of public amenities on malnutrition is also bound to vary geographically. So given that there is such a variation in access to clean drinking water, obviously the impact, how clean drinking water impacts malnutrition will not be constant throughout the state. It will vary. Right? The areas where clean drinking water is difficult to access, the impact of clean drinking water malnutrition, additional one tap on malnutrition will be different from other areas which already have electricity, which already have a lot of water, etc. So therefore, what we will do is, now this is a regression model where every coefficient, if I take n explanatory variables, I have n explanatory variables, each of the coefficient actually has a latitude and a longitude attached to it. Right? Okay. So where U and Vi are, and of course an error term also, which also has a latitude and a longitude. So I have a regression which has very specific spatial dynamics. This is different from the general spatial econometrics, where you have a regression model and you say, okay, space matters. So I'm going to also include the surrounding area as an explanatory meaning, which are called spatially lagged regression, etc. But the coefficients there would still be constant across the state. Coefficients would not vary across. Right? So this therefore becomes a little bit more computationally way. So how is this done? Right. So basically, as I said, beta coefficients here are our usual are x dash x inverse x dash y, where we have a weighting matrix now. Where a weighting matrix, so if you have 340 talukas, you get 343 by 343 matrix with the weights declining in by using this formula, right? Where h is what is called the bandwidth. So h is what says what is the region that I am going to use to construct these weights. Okay, and this bandwidth is the key. Unless you get the bandwidth correctly defined, you don't get the weighting matrices correctly defined. And if you don't get the weighting matrices correctly defined, you don't get the beta coefficients correctly defined. So the key is the bandwidth. Then how do you do the bandwidth? So there is what is called, that is why machine learning comes in. Machine learning typically relies on what is called a cross-validation technique. So it's a cross-validation technique. So you have say 300 villages, right? And suppose you would use a bandwidth can vary from 0.001 to 1. So you will estimate a regression across the 340 talukas, leaving one taluka out for a bandwidth first using 0.01. Then for the same 0.01, you will run the regression over the whole set of talukas again, leaving another different taluka out. Right? So you will take a 330 very pixels for one bandwidth, you do 330 regressions. Then you will predict for each of these talukas, missing talukas. So you will get your forecast errors for particular bandwidth for all those talukas. Then you will change that bandwidth to 0.02 and do the whole exercise again. So again 330 regressions will be done. And you will span this entire range from 0.1 to 2.99 and then choose the one which has the lowest cross-validation error, which fits the best. Right? So that's why we choose bandwidth. And therefore this bandwidth exercise becomes a very computationally large. So in my case, so think of 0.1 to 0.99 for each of the decimals, 350 regressions are being done. Where I have the bandwidth the same for every variable. And then we do it to situations where the bandwidth can vary for each variable, right? So it becomes a very large, complicated exercise, right? Once you do that, this is, so there is a paper by Liang and Liu in 2017, which actually gets a mathematical, which kind of establishes the mathematics behind, having a separate bandwidth, the computational methods for having a separate bandwidth for each variable. But I think you got the general idea, right? Okay, so this is called a multi-scale variable, right? And then you use a test of parameter constants. So do you really need a geographically weighted regression, or a regression with constant coefficients across the entire space will suffice? So this is a kind of an F test, really, right? Where you reject them. If the null hypothesis is that you don't need it. The same way a model with constant parameters for the entire this thing will work, as well as one with variables. And then you can kind of, if you reject it, then it says that a single equation is misspecified. So you need equations with varying, And so I basically in my model it rejects that, right? So what I do is, okay, what I've also done is I'm going to include all the variables in the regression. I need to know what variables to do. So I also use another technique, which again completely intensive. What my model will do is first it will take the dependent variable, then choose one independent variable, then do all these bandwidth exercises, etc. Find the optimal bandwidth for that independent variable, and then establish an Hatekar information criteria for that variable. Then if I got 17 variables, then all the possible permutations and combinations of all those 17 variables will be run in this fashion, and the one which has the lowest AIC will be chosen. So this is what allows me to choose one. This is because I have no other way of choosing what variables should come into my model, because I can't rely on p-values. The reason I can't rely on p-values is because all of you know if there is multi-correlativity, then p-values are not reliable, and a lot of variables are correlated across space. So you can't use t-distribution, right? So what you really do is use that kind of, choose the variables which you have chosen. And now, once you do that, these are the whole host of variables get selected, right? My overall R square is quite good, it's 0.71. Right, so about 70% of malnutrition variation across malnutrition over the space, it's a cross-section regression, is explained by this kind of model. This is an adjusted R square. Right, my raw R square is about 0.85 or something. So I get a really good fit. At least the association and the expected power of that my model is pretty good. Right. What does the model tell me? So, for example, if you look at how to interpret that. This is a regional impact of access to post office and childhood malnutrition. So I get 350 coefficients, one for each taluka. I can divide them like regions. The mean coefficient, mean minus standard deviation, mean plus standard deviation, values stored in that. And then I get, so this picture, so everywhere access to post office, at least large parts of the state actually reduces malnutrition. At least the association is negative. Right? And the association is strongest in this part. Right, but whereas if you come to Gadchiroli, Eastern Vidarbha, then post office is not such a post office is not really having that same impact on reducing malnutrition that they're having in say this part. Right, so if you actually do this, PDS outlets everywhere actually reduces malnutrition. Right, and that you see the coefficients are very similar. So my bandwidth could also be rather global here. Right? Because everywhere access to PDS is a strong negative impact on childhood malnutrition. It's relatively stronger in this region, relatively weaker, but the difference isn't much, minus 0.6 and minus 0.57. So the regional variation of PDS is not much. So PDS is a variable which seems to have a larger global impact. So the multi-scale regression, some variables have a local impact, some variables have a global impact, and PDS seems to have a global impact on reducing malnutrition. What does electricity do? Electricity also seems to have access to electricity. Access to electricity, but actually a significant negative impact on malnutrition, childhood malnutrition. And that impact seems to be reasonably similar across the state. Right? So going from minus 1.62 to about 1.56, that's the kind of regional variation. If I really want to finicky, then this part is where the impact is the strongest. This part. Again, you are seeing the tribal parts of Maharashtra in the Eastern Reservoir. All the policy variables have a relatively weak impact, right?
So you see in Chandrapur, you have a thermal power plant and electricity, which is centered to the region. Whereas it would be less in other outskirts than these areas. So how this equation takes care of the
No, this is Chandrapur is making it. Whereas this is the percentage of households, in percentage of gram panchayats in a taluka, which are at least 50% of households getting electricity for more than between 8 to 12 hours. It is a consumption, not production. Okay? Health facilities, right? Health facilities also, access to PHC, CHC, as you would expect, reduces malnutrition across the state. But again, the impact is very varied. Right? Of course, not as varied as some other things. Rural poverty. Rural poverty has a significant positive impact on malnutrition. But that impact is reasonably diverse. So this is where it has a relatively less impact. But here, poverty is a major driver of childhood malnutrition. Right? In Bangalore, Gadchiroli, Gondia, all that eastern Vidarbha region. Tap drinking water. The tap drinking water you see has a very large variability in its impact. Right? So basically, this part, tap drinking water, access to tap drinking water is strong negative impact on reducing malnutrition. But Bangalore, Gadchiroli, right? This part, especially, these are the real, Naxal affected areas of the state, where access to tap drinking water is not really such a strong determinant of malnutrition. Yeah, because everybody drinks here from a river, and that river is actually quite clean. It doesn't really have that kind of carry. Because tap drinking water essentially becomes important when water sources of pollution. Whereas here, Skip, Pamuga, Uttama, etc., are fairly decent. I've drunk from that water directly, so I don't think really happening.
Many ponds are there in that.
Many ponds are also there. Yeah. Whereas, so basically, this says that there is a lot of variance, right? Female literacy everywhere reduces malnutrition. Right? If women get educated, then childhood malnutrition goes down, but of course differently, but that is not such a dramatically different kind of thing. Access to all weather roads is very interesting. In some parts of the state, it reduces access to roads, reduces malnutrition. In some parts, it's positively associated with malnutrition. Because you don't know what roads do, right? Whatever work is happening now with this data set on a granular and well-identified basis, says that all that it says is what do roads do? Roads take people out of agriculture. That is the only understanding, only real study of regional impact. And that also not in a spatial sense. So we don't know. So what sometimes roads do is, like for example, in my taluka, in the small taluka town where I come from, now markets are, in the market it's very common to see pizza bases in usual grocery shops. People are buying pizza, people are buying biscuits, right? People are buying junk food. Kids' morning breakfast are now being replaced by biscuits, by maida. They're easier, cheaper. Access to roads, for example, can give jobs to people. Everyone can start working, right? There's a lot of things happen within the family, within the household, right? In terms of work allocation, in terms of what family is consuming, what is found to be convenient, so on and so forth. And that impact seems to be very diverse, right? So it's not true that roads will everywhere reduce malnutrition and good for the people. There is really no study on this. The only study that we have to study is, right? All that can definitely say is that roads take people out of agriculture. Go into non-agricultural. But beyond that, really, there is no unambiguous evidence, right? Agricultural employment. If people are working in agriculture, malnutrition is actually lower. There's a negative association with this. I don't know what the reasons are. Again, I'm saying that this is not a causal model. This is a model where you can see only association, right? So a lot of things must be happening. This really gives you reasons to deep dive. Let me find why this is happening a little bit more, right? Access to ATMs reduces financial inclusion is useful for reducing malnutrition, right? And similarly, availability of banks is also reducing malnutrition, except in this part, right? Everywhere else, access to banks actually at the strongest impact is in this part, which is really financially excluded. Yeah, non-working women also reduce malnutrition the similar way. Access to Anganwadis obviously reduces malnutrition in the same way. Availability of markets is a very complex impact. Right? If you have access to this is about at least one a heart or a weekly bazaar, etc., which is access to. Then in some areas it reduces malnutrition. In some areas, actually, society increases malnutrition. So roads and markets, we don't really know what kind of impact they have on money. There is definitely scope to do a deeper study about these relationships. Right? Lack of drainage comes out an important variable. And so if you have better clean drainage, obviously that reduces infection. But again, the differences are across. Immunization also kind of things, right? Scheduled tribe populations are strongly associated with malnutrition. Right? And we know that. Same is with Dalits, right? Especially this part of Maharashtra, there is a larger association with the percentage of people percentage of the population in the village and increased malnutrition. So malnutrition is not only a tribal problem, right? It's also a problem with Dalits, right? Libraries interestingly reduce malnutrition in some parts. If you have access to a public library, right, then you actually have significant impacts on malnutrition, except this part. Otherwise, especially here, right? Maybe I don't know what access to public libraries does. It provides newspapers, it provides information.
Does it have association with female literacy also?
Must be. So we would like to look at these lists. Now, currently, what this is a regression model. So we are now netting out the effect of female literacy. Right. So this is really controlling for people. Right? Okay, but access to public libraries, when everything is the same, better access to a public library actually is associated with lower malnutrition outcomes in a large part of states, except some part where we can say. Right. So impact is varying, right? I don't know what reason. We don't really know. Clean fuel. Households using clean fuel. Right? LPG Ujjwala Yojana is being talked about a lot. That reduces malnutrition, but not everywhere actually worsens malnutrition in this part of it. We don't know why, what is happening. But again, another point where you need to look at it. Why, for example, is this negative association in this part of the state? And why is there in this particular belt of Vidarbha a positive association? And what is really happening in this time frame, right? Narega everywhere reduces malnutrition except this. These are small coefficients, so don't go by this 0 because my Narega days are man days, actual man days. This should actually multiply by 100 to give me the coefficients. But everywhere, Narega generally access to Narega reduces malnutrition, and that's well established. Right? MG Narega has a lot of spillovers. Having more children into school, better nutrition outcomes, and so on and so forth. And this definitely is an important. There are some puzzles, right, which I have not been able to figure out. Schools and malnutrition seem to be positively associated across schools. Probably a way of the data reported. That areas where there are schools, Anganwadi is also better monitored. Where there is greater access to school, Anganwadi is better monitored, so better measurement. So more malnourished kids get caught or whatever. But as I said, again, I'm at the moment focusing on associations. And access to transport also raises malnutrition. So if you have bus, auto, etc. coming in, but again, that ties in with the markets, road transport kind of a larger story. So this basically is my presentation, right? And the idea behind this presentation is what does it do? It helps to kind of devise a regional policy. So if I have a regional plan, right? If I will say district collector and I want to say malnutrition is a crisis problem, and these are the variables I need to look at. It tells me what variables to focus on. If I have a Gram Panchayat, it tells me what are the variables I need to focus on. Right? If I have a block development officer, it tells me what my Gram Panchayat should really be doing. It tells me that I must, because my block, my taluka is a part of a region where certain variables are operating in a certain way. It tells me I must tie together my block development plans with other block development plans in the region. Right? So it actually helps to give you a lot of insight into how granular policies work. So that's clearly one spin-off. You can do this for every state in the country. Not been done. This is only done for Maharashtra. We should do this for every state. Right? So if you like, you can actually introduce these kinds of results, and there's a lot of low-hanging fruit to do this. Right? Inefficient data is there. Inefficient data is district-wise inefficient data is there. All these variables are there for district-wise. You can actually do across India on. understanding the question output. This is now another very interesting database. If you look at the Reserve Bank of India data, it gives you credit data district wise. Right. Now, if you have night times data will tell you what whether economic activity is happening or not. Night lights are being increasingly used, the luminosity of lights at night and its images which come from which are at the resolution of 1 square kilometer. You can actually see how the light illumination across the country has changed over time and what regions are economically active, what regions are not. But this is the aggregate economic activity. But whereas if you look at the RBI data, it tells you agricultural credit, manufacturing credit, personal loans, loans for housing, buying houses, etc. across districts. You can actually quickly see where are the loans being clustered, right? Are personal loans going somewhere? Are housing loans going somewhere? Are agricultural loans going somewhere? How is that geography changing over time? Right? So how are the income? Because ultimately, loans are related to borrowing capacity. And borrowing capacity has to do with repayment capacity. So that has to do with income, right? You can get a good proxy in a more nuanced kind of fashion, right? A lot of things, therefore, can be done using this kind of a method. The shrubs data can be connected with it. You can get a lot of nuanced kind of a policy. The only thing that's happening is, again, another point I wanted to read to you is the whole idea of economics is now changing. It is no longer running cross-sectional variable on 16 different 34 states in the country and reducing something and getting it. Okay? You are now actually having access to a very large data set. The computational challenges are very different now. The skill levels are now different. Right. And therefore, that's also another thing where I think young researchers ought to be moving towards if we want to actually. But there's a lot of low-hanging fruit there. Right. And the third point I want to make is when you look at regional inequality in Maharashtra, administrative division and economic processes can be disjoint. Right? When we think of poverty or we think of access to water, we think of Amravati division, we think of Nagpur division, we think of Nashik division, we think of Kolhapur division, and so on. But processes, economic processes don't necessarily fit in those divisions. So we kind of unearth things from the data. We get the data to tell us. And that ability we now have. So that is to enter the development policy making discourse as much as possible. That is what I wanted to bring to the table today in my presentation. Thank you for coming on the evening and sitting through the late evening. So I hope this was useful to you. Thank you very much.
Sir,
Yeah.
sir, I just want to move on. See, in this data, we have a lot of, in the sense that divisions, hierarchies in the data. Like we find somewhere, like you have 4 regimes.
Yeah.
So can we use, like, I just wanted to know, like, can unsupervised data mining techniques like partitional clustering?
But the problem is
The
what the partial classification is not taking the story of variables. No, for a supervised learning model, you are required to have a Y variable and a model. Right. So unsupervised machine learning methods will give you clusters and all. But will not tell you the geographically weighted relation gives you what are the independent variables and what are the weights. Of course, unsupervised, there is a lot of special unsupervised modeling kind of processes. That's also done. But my particular interest in fitting a policy function, which is regionally very specific.
since you said you just want to focus on regions and
But the regions have come from first. I've not done a clustering exercise. My regions have come from defining the geography, weighted average, and then running the regression across, right? Which is a supervision. Because I put in everything and I let the model choose what are the relevant explanations. Because as I said, we have no theory. Right? And if you have no theory, then you have to learn from the data. I have no way of saying, I can't tell you that I chose post office because the T value is significant because I can't deal with T value on the variable of correlative. So I use the model selection criteria and this specifically takes me. Now what PDS does really, because again I'm saying these are associations, not causation. So there is a story behind it and that story needs to be uncovered. Yeah? That story will give you a PhD. why what post office does and why does post office's impact on malnutrition vary across states and across districts. These are Yeah.
Yeah, so thank you, Professor Neeraj, for a very interesting and stimulating talk. Actually, it opens a lot of questions and puzzles and it answers, and that is
That's all
sign
I
of a good presentation, good discussion. So I was just curious. I think I lost somewhere.
Yeah.
So I think in each graph we are having. So we have a series of graphs here, and in every graph the regime is different, right?
So because
The regime is independent and it is conditional on the betas.
it is conditional on the bit. So basically it is, so for example, if I'm showing graph of post office, then I have geographically weighted regression for all the expected variables.
Right.
PDF post office is one of the variables. There is a beta for each post office, each taluka corresponding to the post office.
Right.
And the spread and the graph that you have was actually of these betas. So I divided into 4 spaces. The mean value,
Right.
mean minus standard deviation. Below that, mean plus standard deviation below that. So the spread of the beta formation
So that defines the regime.
that defines a regime of post office.
Right.
Right, and then we will get a similar regime for every.
And then based on the regime,
Yeah.
are we defining the neighbors?
No,
So we have to define the neighbors a priori.
the bandwidth defines the name.
So that is based on the distance.
The distance, what it does is, so basically it uses an optimization exercise. Right? When I use an adaptive bandwidth, what it does is if I use an adaptive bandwidth, which is 0.1, then it say, okay, let me take 10% of the villages around to pass it. So it will run, for example, for a period.
But that is contiguous or the
Contiguous.
Contiguous.
Right, so you choose the right bandwidth by that cross validation thing.
Right. And I got it.
Yeah.
Thank you.
That's all. Yeah. That's coming.
Public likely correlation in mind. So I look at the enrollment, like the future enrollment rates is also like it shows that high in certain areas.
But we don't have the data for this, right? So we have to work. The key idea of public policy is to work with whatever to make the best of whatever data that you have. That you need to be able to tell a story from a reasonable, good, rigorous story from the kind of wall that you have. Yeah.
So, the variables like post office,
Yeah.
transport, and all, those are throughout the year, like period you.
That's for 2019.
Okay. Onward to.
No, only for 2019. Because that is the latest survey.
You know, those things changed over the period of time.
Yeah, but the latest Antyodaya survey is 2019. And when the pandemic came, so nothing happened yet. So new Antyodaya survey will come this year.
No, but that.
Yeah, so then it is also possible, if I have a panel, then I can also get coefficients which are geographically and temporally linked. And that is entirely possible. It just makes the computation more complicated.
So this is for only for
2019. Fine. But it tells you a story about what to do.
So we can do same exercise for say 10 years. So
Yeah, but you can also
10
put the data in the panel, and then you can actually see how the coefficients vary not only across space but across time. So it will tell you how is the coefficient for Y taluka different from Maharashtra taluka, but it also tells you how the coefficient of Y taluka of post office is different in 2019 and 2015. How that has been evolving. So that's also entirely possible. But computation, as I said, very intensive. So more you put on it, this one exercise takes about 1.5 hours on a i7 processor with 60 GB RAM. So understand the computational weight on what we are doing.
This similar exercise can be done for agriculture distress.
Yeah. Anything you can do this. But if you
So whatever Sambara data that we have, it's not in public, but if, for example, across time we have Sambara data, we have the cropping patterns and
as long as it's geographically, so for example, if you look at the agricultural census, where you have taluka level data on cropping patterns and all that. So that data can surely be mapped.
were there any cropping
variables.
I have not used it, but I want to add this.
Since it's malnutrition.
I should. You're correct.
Conceptually, it is X.
I should be able to do that. And clearly it shows that people in agriculture actually reduce malnutrition. So I can look at the 2015 agriculture census at the block level and then get that data. But as you can make out, getting all this taluka level data, putting in the regression, getting the long exercise. So I will do it by and by.
Taluka numbers are there, Maharashtra, absolutely.
Yeah.
But can we introduce some taluka level variables in this thing?
These are taluka level data.
No, but these are GP numbers that.
No, but these are, I have converted the GP numbers into taluka. So percentage of GP having a previous outlet to the total GP is in that. So actually doesn't at the taluka level. Because at the GP level, I don't have the computing power to do it actually.
So you can introduce direct.
Yeah.
Taluka
Right.
level numbers.
Taluka level, you can actually have to do it also at the GP level, but you will need a big data, so parallel processing and all that. And the optimization techniques are still to be being developed for multiple parallel processing. So it's kind of a mix of economic-based control, and they're quite at the cutting edge of that. Any more questions? No? So thank you again for your invitation. Okay. You're there.
Thank you so for such an insightful session, and also thank you for sharing us with that spatial association, which is, I think, an important aspect of environmental economics and policy making in the India. Thank you. Also, get anyone to write a hacker.